today's video we will learn about elements, compounds and mixtures. So basically what is everything made up of? Matter, right? Everything is made up of matter. What you see, what you feel, what you taste, what you understand, whatever, everything which we see around us is made up of matter. So now matter can be divided into two categories, living and non-living, right? So in living things we know matter is plants and animals. Again in non-living it is divided into homogeneous and heterogeneous. So heterogeneous is always mixtures. Mixtures, whatever you say, whatever all type of mixtures, they are always heterogeneous. And you say homogeneous. So homogeneous is made up of elements, compounds and mixtures. Elements, compounds and mixtures can be homogeneous. Again in elements it is divided into three categories: metal, non-metal and metalloids. Right? Now let's start. Metal is made up of atoms and can be broadly grouped into solid, liquid and gases. However, members belonging to each group or category show difference in properties based on difference in atomic structure as well as the method of formation. Yes, correct. That is the way, because they are made up of different atoms, because they have different properties, because they have different characteristics, we can differentiate them, right? But we can differentiate some elements by elements or mixtures or compounds by the taste, some by the color, some by the feel, some by the when we see them, right? We are able to make the difference. Why? Because they are made up of different, they have different properties, they are made up of different atomic structures and they have different characteristics. Okay? In this chapter, a different system of grouping will be taken up in order to make the study of matter simpler and more systematic. All matter is divided into living and non-living. This chapter deals with non-living matters that are classified as elements, compounds and mixtures. So now let us see, there are few terms to be noted. What are those terms? Let us find. Elements. Pure substance that consist of only one kind of atom. So elements are the ones which consist of only one kind of atoms, right? Suppose you can say hydrogen, you can say oxygen, you can say mercury. Like those, we have many elements in the nature, like they are made up of only one type of atom. Now what are compounds? Compounds are pure homogeneous substances made up of two or more elements combined together in a fixed proportion by weight. So now what are compounds? Two elements mixed together, brought together in a proportionate weight, in a fixed proportion by weight. Means you can actually know that how much of that each metal is mixed into it as per their weight or as per their number. For example, say water. Water is a very good example of compound. In water, which two elements are there? Hydrogen and oxygen. Two atoms of hydrogen and one atom of oxygen. That is H2O, which makes a compound water. Right? So compound is a very good example. Carbon dioxide is another example of a compound. So here we know in compound we will always have a fixed chemical formula which will tell us that how many number of atoms are being got together in a fixed proportion. Okay, so a compound always has a fixed formula. It always has a chemical formula. Okay, now mixtures. A substance formed when two or more elements are physically mixed together in any ratio. Again, a mixture is also formed by two elements, but this will be in any ratio and it will be physically mixed. When you say water, when I say compound like water or carbon dioxide, they are being chemically mixed. By some chemical reaction, they come together. But for matter, when we mix two elements together, it will be in any ratio. Not necessary that it will have a fixed amount of weight, fixed amount of atom coming together. It will be in any ratio. It can be in any ratio and we can also mix it physically. Okay? Then comes metals. What are metals? These are generally solid, lustrous, malleable and ductile. They have a high density, melting point and boiling point. They are also good conductors of heat and electricity. Now, what are metals? So normally metals are in solid form on normal room temperature. On a normal room temperature, metals are always generally in solid forms. Yeah, there are examples in which metals are in liquid form. For example, mercury. Mercury is a metal which on room temperature, on a general room temperature, is in liquid state. So that is why we say that metals are generally in solid state, because we have exceptions like mercury. Okay. Now, they are lustrous. Lustrous means what? That they have a shine. Right? We always see metals normally have a shine. Like you can say steel, or you can say gold or silver, and they always have a shine. The surface is lustrous. And they are malleable and ductile. When I say malleable, what does it mean? Malleable means they can withstand hammering. They will not break down when they have been hammered. Rather than they will get to form into a sheet. Whenever you will hammer it, whenever it will withstand hammering, it will form into a sheet. That is known as the property of the metal forming into a sheet is known as its malleability. What do you mean by ductility? Ductility is that they can be drawn into thin wires. Right? The best example is the copper wires which we use in electricity. Right? For electricity wires, the copper wires, they have been drawn into thin wires. The wires in the cable, they are metal wires, right? So that is the property of ductility. Then what else? They have a high density. They are always, yes, they are metal. When I say density, what do you mean by density? Density is mass per unit. Means how many molecules are there in that particular volume of the size of that particular metal. How many molecules are present in that particular size of that metal. That is known as the density. Density means mass per unit. Okay, mass of molecules or the weight of molecules per unit is known as density. So metals are heavily dense. They have a heavy density. They have a melting point and a boiling point. They have a fixed melting point and a fixed boiling point. And they are good conductor of heat and electricity. Okay. Now, non-metals. Non-metals are absolutely opposite to metals. Okay, they are not absolutely different from metals. Like they exist in all three states. Non-metals, you will find it in liquid state, you will find it in solid state, you will find it in gaseous state. They have a dull surface. They cannot be beaten into sheets and drawn into wires. They have a low density, melting point and boiling point. And they are bad conductor of heat and electricity. Now, what are metalloids? Now, metalloids are the ones between the metal and the non-metal, means they might have some property of a metal and some property of non-metals. Okay, so a group of elements that show property of both metals and non-metals are known as metalloids. What is homogeneous? As I said, that mixture, I told you that homogeneous are elements, compounds and mixtures can be homogeneous. So what is homogeneous? The substance that has same property or characteristic throughout its bulk. Like the best example for an homogeneous is an iron part, an iron metal iron. Like the tiniest particle of iron will also get attracted to a magnet, whereas a very huge block of iron will also get attracted to the magnet. So from the tiniest to its bulk, the property of iron remains same. So that means iron is homogeneous. Right? Means from the tiniest particle to its bulk, the properties do not change. The properties will not change. That is why they are known as homogeneous. Now what are heterogeneous? The substances that do not have same property throughout its bulk are known as heterogeneous. So now, before learning exactly about elements, compounds and mixtures, let us first learn about atoms and molecules. Yeah, with which the elements, compounds and mixtures are made up of. So what is an atom and what is a molecule. The word atom was first used in the 5th century BC by Greek philosopher Democritus. He adopted the word atomus from Greek word meaning indivisible. Why indivisible? Because before they used to think that atom is the tiniest particle of the element and it is not divisible. Okay, that is why they used to use it as the word indivisible. Okay, but then in 1897, J.J. Thomson put forth the idea that atoms could be split up to give smaller particles, that is electrons, that carry negative charges. But we also now, with further studies and researches, we have come to know that atom is basically made up of 3 particles, that is protons, electrons and neutrons. So neutrons carry no charges, protons are the positively charged and electrons are the negatively charged. Okay, so it is now known that nucleus of an atom contains 2 kinds of particles, protons and neutrons. Protons are positively charged while neutrons carry no charge. And then, so atom is made up of 3 parts, protons, electrons and neutrons. But the number of protons are always equal to the number of electrons in an atom. So, and the neutrons do not carry any charge. So, as such, in a free state, the atom carries no charge, or it is neutrally charged, because it has equal amount of positively charged particles and negatively charged particles. So that makes the atom absolutely natural, electrically natural. So in an atom, the number of protons are equal to the number of electrons. Since the number of positively charged protons and the number of negatively charged electrons are equal, an atom is electrically neutral. Now we can see the atom as our solar system, right? How in the solar system the sun is in middle and the planets revolve around the sun. In the same way, in an atom, the positively charged nucleus and the neutrons, they are in the center, and the negatively charged electrons, like planet, revolve around it. So you can take an example of our solar system. Our atom is somewhat like that. Okay. Now, what is a molecule? So what happens is, an atom can not always survive. Mostly atoms are not stable. Okay, they cannot exist in a free state in a single form. Single atom cannot exist freely by itself. In order to become stable, the atom needs to join with another atom of its own kind, or with the atom of another element, and form molecules. Means when atom of the same kind or atom of 2 different elements, when they come together, they form molecules. Okay. Now there are some terms we need to note. An atom is the tiniest or the smallest part of an element that can exist and still have the property of the element. Means the tiniest particle of an atom of the element will have the same property as the whole or a bulk. As I had explained you previously, the best example is iron. This one single atom of iron will also get attracted to magnet, whereas the whole piece of iron will also get attracted to a magnet. Iron is an element. It has the property of being attracted towards a magnet. Now, if the iron is broken into small pieces, the smallest particle that can be attracted towards a magnet is the atom of the iron. The second point to be noted is, atoms join up to form molecules, right? Atoms of some elements cannot exist in free state. So what happens? They need to combine with an atom of their own element, or they get combined with an atom of some other element to form a molecule. Molecules are the smallest particle of an element or compound that can stand on its own. The third point is, molecules of elements contain one or more atoms of the same kind. Now the example is hydrogen. Okay, so when I say that hydrogen, one atom of hydrogen plus another atom of hydrogen will give you H2, that is a molecule of hydrogen. So two atoms of the same element, one atom of hydrogen and the other atom of hydrogen, will make a molecule of hydrogen, that is H2. And there was another example where I said that atoms of two different elements can also come together to form a molecule. The example over here is hydrogen chloride. So H denotes the atom of hydrogen and Cl will denote one atom of chlorine. So now when these two come together, when the two atoms combine, they form one molecule of hydrogen chloride. So one molecule of hydrogen, one atom of hydrogen plus one atom of chlorine will give you hydrogen chloride, that is HCl. Okay, so now so that we know what are atoms and molecules, let us start learning what are elements. So elements are pure substances that are made up of only one kind of atom. So one element, that means it is a pure substance. Elements are pure substance which are just made up of, if I say iron, the element iron, it will contain only atoms of iron. It will have atoms of no other element. So elements are pure substance which are made up of only one kind of atom. Okay, so see, all atoms of an element contain the same number of protons and electrons. Atoms of different elements differ from one another with respect to number of protons, neutrons and electrons, which are the subatomic particles. So what does this mean? That an atom of one element, like the atom of iron, if I say the atom of iron, or if I say the atom of mercury, or if I say atom of hydrogen, atom of oxygen, whatever, they will, the atom of oxygens, all the atoms of oxygen will have the same amount of electrons, protons and neutrons. All the atoms of mercury, in an element mercury, will have same amount of elements, electrons, protons and neutrons. They might differ element to element, means the element iron might have different number of electrons, protons and neutrons. The element mercury might have different number of electrons, protons and neutrons. So in short, different elements, different types of atoms and different types of protons, electrons and neutrons. Now occurrence of elements. So how do they occur in universe? What element occurs abundant in the universe? What element occurs abundant in the earth crust? And which element is the most in human body? So in the universe, hydrogen and helium are the commonest element, and they are the main elements present in stars, making up 98% of their matter. In the Earth's crust, oxygen is the most abundant element, followed by silicon. Together they make up nearly 3/4 of the crust. And in the human body, that is in our body, this carbon, hydrogen and oxygen are the most common elements, as they are the main constituent of the substance that make up the body cell. Among the metallic elements, copper, silver, gold and platinum are found in the uncombined state, as they occur very low in the activity series. So far we have got 118 elements that are known to us. So far there are 118 elements that are known to us, out of which 89 elements occur naturally, whereas on the Earth's crust, whereas 20 have been created artificially. Now, only a few of natural elements exist freely in nature. Most elements are so reactive that they join with atoms of other elements and exist in combined states. So now reactivity. What do you mean by reactivity? That is that let's understand the reactivity of elements. And the best example again over here will be iron. Okay. Now let's say pure iron is shiny grayish white metal, whereas gold is shiny yellow metal. We know that metal have luster. Luster, that is they have shine. So iron is a grayish shining metal, whereas gold is a yellowish shining metal. Now When on prolonged exposure to air, a reddish brown layer forms on the surface of iron. Why? Why is the reason? What is the reason behind it? That is that iron is very reactive when exposed to air. It reacts with the oxygen in the air and a reddish brown layer known as rust is formed on iron. Whereas gold, we wear gold jewelry, right? Gold jewelry, they never get rusted. Why? Because they are not reactive. Gold is a metal which is not reactive. It remains unchanged after a prolonged exposure to air also. Okay, so here we can say that gold is a non-reactive metal or a less reactive metal, whereas iron is a very reactive metal because it reacts very fast, combines with the oxygen in the air and forms rust. That is known as reactivity of metal. Now, again the elements exist in all three states. On a normal temperature, on the room temperature, element exists in all three states. That is solid, liquid and gas. Even though elements that are solid, liquid or gas under normal conditions of temperature and pressure, can be made to change their state by suitably changing the temperature or pressure. So you can change a solid into a liquid or a gas, or a liquid into a solid or gas, or a gas into liquid or solid. Elements can be changed into different states when they are exposed, when they go through a certain change in temperature or a certain pressure in temperature. Now, under normal conditions, there are 2 liquid elements and 11 gaseous elements. The rest of them are solid elements. So out of 118 elements, 2 are liquid elements, 11 are gaseous elements and the rest are solid elements. Of all the elements present, oxygen is the most abundant element in the Earth's crust, while nitrogen is the most abundant element in the air. Oxygen is second to nitrogen in air. And elements can be grouped into 3 major classes: metals, non-metals and metalloids. We all know now, by now I have explained you previously in this video what is a metal, what are non-metals and what are metalloids. Now let us see what are compounds. A compound is a pure homogeneous substance made up of 2 or more elements combined together in a fixed proportion by weight. Compounds can be decomposed into simple substance by chemical methods only. So, what do you mean by compound? Is a homogeneous substance. When I say homogeneous substance, that means that you know exactly what elements are contained in the compound, in what quantity and how are they combined. Okay, so it is a pure substance, homogeneous substance, and it is made up out of 2 or more elements combined together, and they can be combined only through chemical means, and they can be separated also only through chemical means or chemical methods. Okay, matter in which 2 or more elements combine chemically in a fixed ratio by mass such that the original property of the elements are changed are called compounds. Okay, so when the 2 elements come together, the property of those elements change and a new substance is formed which will have properties absolutely different than the component elements, than the elements through which that particular compound is formed. It will have absolute different properties. Let's consider the properties of elements hydrogen and oxygen. Hydrogen is a combustible gas, that is it catches fire and it burns. And oxygen is non-combustible gas, but it supports combustion, that is other substances can burn in presence of oxygen. So hydrogen burns itself, whereas oxygen doesn't burn itself, but it only helps in burning. But what will happen? See, if 4 grams of hydrogen and 32 grams of oxygen, that is in the ratio of 1:8 by mass, are taken together in a flask, there will be no change observed. Why? because we are just physically we are putting oxygen and hydrogen together. But however, if an electric spark is passed through the flask, a colorless liquid is formed. Now what is that colorless liquid? Colorless liquid, that is water. Okay, so now see, we said that hydrogen is combustible, oxygen is non-combustible, but it supports combustion, right? But water, what does water do? It is a mixture of hydrogen and oxygen. Okay, but water will have absolutely a different property than hydrogen and oxygen with which it is made up of. Water is a non-combustible, that is property different from hydrogen, and a non-supporter of combustion, that is a property different from oxygen. Therefore, water is an example of compound. So it is always like that in a compound, when two elements come together by a chemical method, they will have properties absolutely different than their component elements. Now, it is made up of two elements, hydrogen and oxygen, in a fixed ratio by mass. That is how compounds are made. The two elements, hydrogen and oxygen, were made to combine by chemically. The property of water are entirely different from those of the constituent elements. And water cannot be broken up into its constituent elements by simple method like heating or by any other physical mean. And water is homogeneous. Now we will learn what are mixtures. A mixture is made up of two or more elements or compounds mechanically mixed together in any proportion such that its properties are those of its constituents. Okay, so what is mixture? Mixture, when you mix those two elements or two compounds together in any proportion, in any mass, in any which way, and you can mix it physically also, they can be separated physically also, and they will always have the property of their constituent elements. So now a mixture is a substance formed when two or more elements or compounds are physically mixed together in any ratio. Let's see some example. Take some powdered sulfur and iron filling in separate saucers. Iron is greyish white metal. When a magnet is brought near it, the fillings are attracted towards a magnet and stick to it. Sulfur is yellow solid. When a magnet is brought near powdered sulfur, the sulfur remains unaffected, that is, it does not get attracted towards the magnet. Now, take spoonful of iron fillings and powdered sulfur and mix it together in a saucer. The yellow specks of sulfur and grey metal particles of iron can be seen separately. When a magnet is brought near the saucer, only the iron particles are drawn towards the magnet. The sulfur particle remain behind in the saucer. Thus, the constituent can be separated by simple physical means, and it also proves that the constituents do not lose their property. Iron without mixing used to also get attracted to a magnet. Iron after mixing with sulfur powder is also getting attracted to the magnet, and sulfur powder remains unchanged. So the distribution of iron and sulfur particle is not the same throughout. In every given sample, the proportion of iron and sulfur will vary. This is an example of a heterogeneous mixture. All mixtures are heterogeneous except solution mixtures, those are homogeneous. Now, we know now what is a heterogeneous and homogeneous substances. Now, let's see why do we say that all solutions except solutions which are homogeneous. Why are they homogeneous? Add some salt to water and stir well. Taste some of the solution. A colorless solution is formed which is uniform throughout. The particles of salt cannot be seen separately as distinct from the water molecules. The salty taste persists throughout the bulk of the solution. If the solution is heated, the water evaporates and the salt can be recovered as a residue in the saucer. From the example discussed above, you now can compare the characteristics of compounds and mixtures. So now, what is a comparison between compound and mixture? Now see compounds. They are made up of elements in a fixed proportion, whereas mixtures, they are made up of element compounds or of different components. The compounds, they are always homogeneous. The components of the homogeneous substance cannot be seen separately. They may be mixtures, they may be homogeneous or heterogeneous. Compounds, their properties are different from those of the elements of which they are made. Mixtures, the component of the mixture retain the original property. In compound, it cannot be broken up into its constituent elements by simple physical method. Whereas in mixture, the various components of the mixtures can be separated by simple physical means. A compound, formation of the compound generally involves the absorption or evolution of heat, that is either heat is absorbed or heat is released. Whereas in mixture, formation of the mixture does not usually involve absorption or evolution of energy. So this was all about element, mixtures and compounds.